So what was that? You were talking to me or talk to her?
I was talking to Michelle.
Oh, okay.
But Ed, you okay if I record this class?
Yeah. Just give me a second. I have to write down the information.
Sure.
Okay, Michelle, can you see this?
Yeah.
Okay. So it says there are two triangles, ABC and BDE. These two triangles are equilateral, like they're equal. The side, the angle, all equal. And we know AC is 3x plus 4. We know DE is 5x minus 4. And we know AB is 5x plus 5. We try to looking for BE. So how should you find it?
So can you put an equation? Is that what you mean?
How should we put the equation?
So 3x plus 4, 4x plus 5, and plus 5x minus 4 equals 180.
Nope. It's not about the angle. It's the side. The side AC is 3x plus 4, and DE is 5x minus 4, and AB is 4x plus 5. So we try to looking for this BE. There's no 180 because we are not talking about the angle right now. We're talking about the side, the long. So we know first, because we know triangle A, B, C equal to triangle B, D, E. So right now we have, that's a given information. So what should we do about it to find this line?
So 4x plus 5 is the side of AB, and then 3x plus, okay.
So because first we know they're same, so we know this line is equal to this line. So first, 3x plus 4 is equal to 5x minus 4. That's step one. After this, we can solve for x. So what's x? X is both side minus 3x, 2x left. Both side plus 4, we have 8. So x equal to 4. After we find out x equal to 4, that's step 2. After we find out x equal to 4, we can plug x equal to 4 inside of this equation to find the line of AB, because AB equal to BE, because these two triangles are equal. And so AB is 4x plus 5, x is 4, which is 4 times 4 plus 5, which is 16 plus 5, which is 21. Therefore, BE is 21.
Okay.
Did you get that, Elana?
Yeah.
Well, I think that, Ed, correct me if I'm wrong. You're very good at math, but I think the key is in like two steps, right? One is, understanding that AC is equal to DE. Therefore, AB will equal to BE because these are equilateral triangles. Yeah, Ed,
Yes.
right?
Yeah.
Yeah.
The equilateral triangle is given by the questions, so we already know it's an equilateral. So yes. AB is equal to BE for sure.
Right. So and then once we understand that AB equals BE, you with me, Elana?
Yeah.
Once we understand that, because we know it's an equilateral triangle, so therefore AB equals BE. Now the question is, what is X? Now the key is in finding the X. Yes, Ilana?
Yeah, I got it. Okay.
Yeah, so key is finding X, and we know 3x plus 4 is AC. That equals DE, that is 5x minus 4. So you just put them on, 3x plus 4 equals 4x minus 4, 5x minus 4. Then you solve for X. Now, are you clear on the steps to solving X here?
Yeah.
Okay, cool. Yeah.
Okay. Let's see a new question. Okay. So right now we have a we have a triangle here. It's A, B, C, D. And we know this is 90 degree and this is 90 degree. So given triangle ABC, BC is parallel to AC and CD is like perpendicular to AB. So prove that AD times AB equal to AC squared. So proof AD times AB equal to AC squared. So how should we do this question?
I've never really learned this part of the equal to AC squared or anything.
Oh, you never learned it?
No. We sort of learn like simple ones, simple proofs.
Okay, so basically, when you see this question, you can think about this. So AD times AB equal to AC squared. Let's see, how should I say this? Okay, so first we can see obviously, which is AD is shorter than AC and AB is longer than AC. For this triangle, right triangle, AD is the let's see, how should I? So you haven't learned this before, right?
No.
Okay, let me think. If she haven't learned this, should we go over or we don't do it?
What do you think, Ilana? Is it a new concept that you want to delve into, or you rather focus on things that you, because I think exam is on what, Friday?
Yeah.
Yeah. So what is your gut feeling? Do you want to learn new concepts, or perfect the ones that you have little familiarity with?
Yeah, I think we should go over the ones that I need more help on.
I think that's a smart decision. Yeah, I think that's a smart move. Yeah.
Okay, so let's see. Okay, so let's try this. 怎么了? Okay, so right now we have a parallelogram. And we have A, B, C, D, E, F, G. So we know it's a parallelogram. ABCDDE is equal and parallel to BF. So for triangle CEG, this triangle and this triangle, to prove their equilateral triangle, by which one? By AAA, AAS, SSA, or HL. So to prove this two triangle, you have four choice, which is A, S, A, H, L. So which one do you think is right?
I think is G a right angle or?
We don't know that.
Okay, so then SA.
You mean SSA or what?
Yeah.
You mean this one? Why is that? Why do you think it's SSA?
Because the two triangles are congruent.
So okay, so which side you think? Which two sides you think are equal?
AG and CG.
AG and no, we don't know that for sure right now. I mean, yeah. I mean, you can see that. That's also right. So AG and CG is let me think. Okay, AG and CG. Okay, what else?
EG and FG.
Okay, and the angle G, right?
Yeah.
Okay, and also not only that, you can also do, yeah, that's one. And remember, AS is also the right because A is angles this ECG and GAF. These two angles are equal, right?
Yeah.
And I will tell you why you get it wrong. Your answer is not right. Let me tell you later. Okay, so you have this angle and this angle. That's A, right? Second angle, this angle, and this angle. Their two angles are equal, right? And the side, which is you said, either CG, AG, DEG, or GF. That's right. But the point you get wrong is SSA is not the proof to find the equilateral triangle. SSA is not a equilateral triangle. AAS it is. The four things you can to prove it's a equilateral triangle, which is S, 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 A, S, A, S, A, S, and A, S. That's we mentioned yesterday. There's no SSA. So SSA, you look, it's right, but it's not. Because SSA is you cannot prove. I will tell you why. So one triangle can be look like this. And another one. Okay, so in this series, like this situation, this side and this side are equal. They have one side equal. This side and this side are equal. There are two sides equal. This angle and this angle are equal. Are they the equilateral? No. That's why SSA cannot be the reason to prove it's an equilateral triangle. You only can prove the triangle are equal by AAS. You cannot prove the triangle are equal by SSA. Remember it. The only four things can prove is this four. SSS, ASA, SAS, and AAS. There's no SSA.
Okay.
Is that clear, Alana?
Yes.
Okay, let's see. Okay. So you have a triangle 2 square root 3. So what is the perimeter of it?
I never learned that one either.
You learned it, but you just don't know how to find it. There's a special things for this equilateral triangle. You have, this 3 sides are equal, 3 angles are equal, right?
Yeah.
So what do we know about it? We know every angle is 60 degrees. Is that correct?
Yeah.
So we know every angle is 60 degrees, and we separate into half, which will be 30, 60, 90 degree triangle. Is that correct?
Yeah.
So what's special of 360, 90 degree triangle? Do you know that?
No.
Oh, you don't know that part?
No.
Oh, but it's on your test. So, okay, let me tell you. So when you have a triangle, so when you have a triangle like this, here is 30, here is 60, here is 90 degree. Here, for example, here is 1. You will have 1/3 here, 1 square root 3 here, and you will have 2 here. That's a special for, oh no, it's not for you right now, so let's just do your tests. Congruent triangle, let's see, what else? What else? Okay. Have you learned a circle yet?
Certain circles.
So you learned the equation of circle?
Yeah.
Okay. So right now we know a circle center is 3 and -2. That's your center. So you have 4 equations. One is x minus 3 squared plus y plus 2 squared equal to 4. Second one, x plus 3 squared plus y minus 2 squared equal to 4. Third one, x minus 2 squared plus y minus 3 squared equal to 4. Fourth one is x plus 2 squared plus y minus 3 squared equal to 4. So for the center, x, y is 3, -2. What's your equation?
Number 1, the first one.
Okay, so let me just ask one more further. What's the radius of the circle?
2.
Yes. Okay. That's nice. Okay, you have a circle center with -3 and 1, radius is 7. So what's your equation for the circle? You have center -3, 1, radius is 7. So what's your equation?
X plus 3 plus y.
You have square, don't forget. Square.
Plus y plus 1 squared.
It's y minus 1 because it's positive 1 here.
Oh.
I mean, wait, your here is x plus 3, right?
Yeah.
So if you get -3 here, so that's why you plus 3. So it's 1 here, that's why you minus 1. Don't forget. Okay, equal to what?
14.
Why it's 14?
Because you multiply the 7. Is 7 the radius or?
Yeah, 7 is the radius.
Okay, so then you multiply 7 by half, which is 14.
Okay, let me clarify. It's radius, you do not times 2. You use the square, which is 7 squared. You should be equal to 49 instead of 19. Instead of 14. You should equal to 7 squared, not 7 times 2.
Okay.
I have to clarify that for you. Okay, so you will have x plus 3 squared plus y minus 1 squared equal to 49.
Oh, right. Okay, I remember that.
Okay. Let me give you a question. It says you have this. And if this clockwise, okay. Clockwise rotate 270 degree, what your point be look like? You will have, your arrow should be face to here, or face to here, or face to here, or going down. So you have 4 things. So which one should be your answer? If this angle rotate 270 degree, which one should be equal? Like which one is after rotate 270 degree by clockwise?
The first one on the left.
This one?
I can't see the.
Yes, it's this one. Yeah.
Yeah.
It's, okay.
That didn't take long for you, Alana. That was smart.
Thank you.
Okay. A right triangle ABC, ABC. We know measure A is 90 degree. That's a right triangle. And the measure C, this angle is 3y minus 10. This one is y plus 40. I want you to tell me, is that a isosceles triangle or equilateral triangle or obtuse triangle or it's a, like, what is y? What is the 2 degree of this 2 angle? Let me just skip like isosceles, equilateral, that part. Just try to tell me what is the degree of angle B and angle C.
Did I just say y? Just y plus 4?
No, 40. That 0 is too far, so I erase it. Rewrite it. So angle C is 3y minus 10. Angle B is y plus 40.
Hold on. Y equals 15.
Y equal to 15. Why is that?
That's smart.
Because you put the two equations together, so 3y plus 10 equals y plus 40.
3y minus 10 equal to, no, why is 3y minus 10 equal to y plus 40? Why you say that's two equal? I didn't tell you it's a 45 degree triangle or isosceles triangle or what. I just give you this 2 equation. I said this angle C is by this degree and angle B is this degree. And I try to let you to find what's y is. That's step 1. Try to find out what's y. And step 2, to find out what's degree of C and degree of B. We do not know angle C or angle B, they're equal or not.
Well, 15 is correct answer, but I don't know how you got there, Alana. Yes, Ed? 15 is correct answer. Y is 15, isn't it?
Let me see.
No, I think I did it wrong. I put y plus 10 sides instead of 3y minus 10.
15 is the correct answer, but the way you just told me isn't right.
Yeah.
Yeah, I just did the math wrong and I got 15.
You got lucky there.
And so, okay. So right now, it's about the total angle of triangle. So total of this triangle is 180 degree, right?
Yeah.
So we have a 90 degree here, which is minus 90. You have angle B and angle C, left over 90 degree left. Therefore, 3y minus 10 plus y plus 40, you should equal to 90 degree. Do you know why for this one?
Because the triangle is a 90 degrees.
Yes, left 90 degree for right. Okay, then we can see. Okay, so how many y it have? 4y. And minus 10 plus 40, which is plus 30, equal to 90. Therefore, y equal to 15. That's how you get 15. It's not by lucky. Okay.
Did you get that, Elana?
Yeah.
So basically, you know, triangle has 180 degrees in total, and you already know that A is a right angle triangle, so that is 90, right? So angle C and angle B put together should be 90. You're still with me?
Yeah, I'm still here.
Yeah, so, you know, we know angle C is 3y minus 10, angle B is y plus 40. You add them, that should add up to 90. And you go on solving that, you know, you would get y 15.
Okay.
Okay, after you get y equal to 15, do not just like say, okay, I got y. You still have to find out what's degree of B and C. So you have here y equal to 15. 15 plus 40, you have 55 degree. And here, C, you have 3y minus 10. You can just plug 15 inside to find out. Or you can just use 90 minus 55, which is left 35 degree. Then you know what's the 3 degree right now. 35, 55, and 90 degree. That's how you find it for 3 like angle measurement.
Okay, I got it.
Okay, let me see. Okay, have you learned like, let me see. Have you learned this before? Like, so that's, let's see, that's line 1, line 2, line 3. That's 3D dimensional graph. So we know line 1, line 2 are perpendicular, and line 3 is across, like top to bottom perpendicular. Have you learned this before?
Yes.
Okay, so right now we have this graph, this graph, line 1, line 2, line 3. So which statement is true? So first one, line 3 is perpendicular to the plane determined by the plane of L1, LB locate. So L3 is located to the graph. Or line, let's see, line, line 1 and line 2, it says you have to pay for
Nope. Don't
okay.
worry about it. I took care of that, Ed.
Okay. It says lines. Okay, so you have this graph. So I don't know how your teacher going to tell. For me to look at this question, it's just try to let you statement like which is true. So for this graph, you have to know line 1, line 2 is on a plane. They're on the same plane. So when it says line 3 is perpendicular to line 2, line 1 plane, that's true. And you can rotate this graph to make it line 2, line 3 on a plane, and line 1 is perpendicular to this plane. Or you can rotate the graph to make it line 1, line 3 is perpendicular, and line 2 is goes through it. So you can, it didn't have any more question, like more further question to find it. So I don't think your teacher is going to ask really hard question about it. So probably I will just stop over here. I don't want to waste your time to do this. Okay. Let's see. Okay. It's a parallelogram.
Do you have access to the questions, Lena? Do you know what Ed is talking about?
I don't have the questions with me.
You don't have the questions with you. Okay, so we'll explain it to you.
That's N O B R X. So proof triangle B and X is equal to triangle O R X. Okay, how should you prove it? How should you prove them they're congruent triangle? Like,
You know, I think Ed, from the text you said it is a parallelogram, right?
yeah, it's a parallelogram.
So that's all we know. Okay. We know B and OR are parallelogram. Any ideas, Ilana?
Oh, by the way, it didn't say it's a parallelogram. It only says the diagonal NR and BO bisector each other by X, which means they only tell you this line and this line, these two lines are equal. It didn't say it's a parallelogram at all. So that's really important, because if it says it's a parallelogram, you're going to prove by different way. It only says the diagonal bisector each other by point X. So how should you prove B and X, this triangle, are equal to this triangle? How should you prove it?
I'm not sure.
Just say it. We're going to have like, just say what you know. Like, tell us what do you know you can tell from this graph.
That N and R are congruent and B and O are congruent.
So, pardon? Can you say that again? I'm going to draw on the graph.
I just said that N and R are congruent.
And R and it says NR and BO bisector by point X. So what it says, which is bisector, means cut into half, right? So which is NX and RX are equal. That's we know, step one. Second, bisector BO at X, which is BX and OX, they're equal. That's step two. Now you have two sides. Step three, these two angles are equal. Therefore, we have S, A, S. Can you see it?
Yeah.
And S, A, S is a way to prove the two triangles are equal. Do you get it?
Oh, so because B and BX, OX, and X and RX are equal?
Yes.
Okay.
It didn't say it's a parallel or what, so we don't know about the other angle, other line. It only says BO and NR are bisector at point A. So we know this line and this line are equal. This line and this line are equal. So it gives us two equal line. And we know this angle are equal. Therefore, we have SAS.
Okay.
You can say it now, right?
Yeah.
Okay. Okay. You have a triangle, and here is x degree. Here is 2x plus 1 degree. Here is x plus 15 degree. So what is the largest angle in the triangle? Which angle is the largest one?
What is the first one say? 2x plus.
2x plus 1. That's degree. So which angle is the largest one?
X plus 15.
Why? What do we have to do first?
Do you solve for x?
Yes, we're going to solve for x. So what is x? What do we know about the triangle?
It's an equilateral triangle.
Nope. We do not know that.
In fact, it cannot be equilateral triangle, Ilana, because we have x and we have x plus. So even if x was 60, there is x plus. There is one other angle that is more than 60.
Yes, yeah, it cannot be, yeah.
It cannot be equilateral triangle. You see that, Ilana? Because, yeah, so it cannot be equilateral triangle. But, you know, again, it's the same principle like the last time. You know, all the angles put together should be equal to
180.
There
Right.
There we go.
So 2x plus 1 plus x plus 15 plus x. So this triangle should be total equal to 180. Then you solve for x. Total, you will have 4x plus 16 equal to 180. 4x equal to 164. X equal to 41. Then you're going to plug 41 inside of those equations. So we know this angle is 41, and here is 41 plus 15. So 41 plus 15, you will have 56 degrees. And for this one, you can use 180 to minus this and minus this. I will just plug inside, which is 82 plus 1, which is 83 degrees. Therefore, the largest angle in this triangle, it will be 83 degrees. You know it, right?
Yeah.
Okay.
Yeah, I think, you know, it all hinges on the principle that internal angles put together should be 180, and you go on solving from there.
Yeah.
You know, that is a bedrock principle of triangles, isn't it, Ed? I mean, no matter what triangle you take, it is 180 degrees, and you start from there.
Okay, let's see another one. Okay, this question is, you have a rectangle. You have another triangle like, wait. Okay, you have this two triangle. And we know this 90 degree, and this is 90 degree. That's an triangle A, B, C. That's triangle E, D, F. The question tells you CA is perpendicular to AB, and ED is perpendicular to DF. And we know ED is parallel to AB, and CE and equal to BF. So these two lines are equal. We know these two lines are equal. And we know AB is equal to ED. AB equal to ED. And measurement CA. Okay, so how should we prove ABC equal to triangle DEF? By which one? By SSS? By HL? By SAS? Or by AAS?
So those are the four multiple options?
Yes, this is for multiple options. Which one is right?
HL.
Why is that?
Because you're proving two right triangles.
Okay. So we know AB equal to DE, right?
Yeah.
And how should we know CA is equal to DF? That's your height.
First, we know that CD is equal to DF.
CD? Oh, we do not know AC equal to DF at all. We do not know that. We only know ACE equal to BF. That's what we know.
Well,
okay, so okay, go for it.
Why don't we do process for elimination, right? We know H and L is not an answer. So, did you recommend that, Ed, or do you recommend directly going for solving it?
I will recommend go solve it, because if the teacher do not give you multiple choice, teacher just said prove it.
Yeah.
There's no way you can just
Yeah. Sorry.
Okay, so we can see from this two triangle, these two lines are perpendicular. So that's our first angle. We know this angle are equal. Therefore, we have 1A here. Then let's see what else we know. We know ED and AB are equal. These two lines are equal. Therefore, we have a side. We have AS already. Then we're going to find what else we know. We know CE. We know BF. Why the question give you that? Because the question try to tell you this part is the shear. This shear line, they have to be equal. BE, the shear this part. So it means CE plus BE equal to CB. And this side and this line are equal. This line, the shear. Therefore, BC equal to EF. If BC equal to EF, you have another side, right?
Yeah.
You have third side. Then what we know about it. If triangle, right now you have SA, but that's not how you're going to prove your triangle the right triangle, because I just said when you have SA, you cannot prove it. So we also going to see what else we know. Okay, we have this line and this line are parallel. This line and this line are parallel. So what we know, this angle have to be equal to this angle. Is that correct?
Yeah.
Okay, now we have SAS. Can you see it?
Yeah.
Now we have this line, this angle, and this side. SAS, SAS. Therefore, these two triangles are equal. So your choice should be SAS. We do not know the height at all. So you cannot just say the height look the same, but they're not.
Okay.
Okay.
Yeah, this is a tricky one, isn't it, Alana?
Yeah.
Yeah. You know, when you're given multiple choice, you know, don't go for the tempting one, you know, easy one, right? That looks, there's a reason why it's there.
Okay. Okay. You have this one I think it's easy. You have a roof and it's a isosceles triangle, and that's x. That's 84. So what should be here? How many degrees is this one?
Um, 84
Why?
because it's an isosceles.
Isosceles means these two sides are equal.
Oh. Or 96.
Why it's 96? If you have an isosceles triangle, then if that's 96 means you have 84, 96, and another 96. That's totally not 180, right?
Yeah.
So to solve this question, first, this triangle total 180, that's for sure. We talk about like several times. 180 minus this angle, you have 180 minus 84, left 96, right?
Yeah.
96, which is this two angle total is 96. So 96 divided by 2, because they're equal, means these two angles are equal. So 96 divided by 2, you should have 48. So each angle is 48. That's how you find it.
Did you get that, Alana?
Yeah, I'm writing it down.
Okay.
Okay. Let me give you a little tricky question. Okay.
Uh-oh.
Okay. You have a... Okay. So here, you have triangle A, B, C, D, E. And we know this triangle AB is equal to BC. No, AB equal to AC, which is this line is equal to this line. And we know BD is 1/3 of BA. So this is 1/3 of BA. And CE is 1/3 of AC. So here is also 1/3. Tell me why these two triangles are equal, like triangle BDX and triangle ECX. Why these two triangles are equal? Wait a minute. Let me try to give you a better one. It's EBC. Okay, let's try to do this. Do now do this. This will be a little harder, easier for you. BCE. So proof triangle BEC is equal to triangle DCB. by what? By SSS, by HL. What H look like? Or ASA, or SAS. Which one is that?
I know it's not HL.
Yes, it's not right triangle. I mean, it could be, but we don't know that. So, okay, so which one should be? Which one?
I'm not sure.
Okay, tell me, like, what do you think?
ASA.
Why is ASA?
Or
Okay, so from this graph, we can tell like it says AB equal to AC, which means that's isosceles triangle, right? So these two lines are equal, right? By that, we also know angle B is equal to angle C, that's right? So we know this angle are equal. That's give us one angle. And the same line, which is BC. So we have a side. So we have S, A here. Then what else it says? It says 1/3. If here is 1/3 and here is also 1/3, and that means BD equal to EC.
Mm-hmm.
If BD equal to EC, then these two lines are equal. Then you have the second line equal, which have SAS. 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 You get it?
no, not really.
Okay. So at first, it's an isosceles triangle. Therefore, angle B and angle C are equal. Do you know why is that?
Say that again. Sorry, I couldn't.
Okay, it's an isosceles triangle. So line AB, line AC are equal. Therefore, angle B and angle C are equal. Do you know why is that?
No.
Because isosceles triangle, your two side, the two equal side, your angle should be the equal. That's the theory for the isosceles triangle. Therefore, so your triangle, let me take it out. So your angle BDC, this one, that's your angle BDC. That's part of your isosceles triangle, right? And this angle is here. So this angle should be equal to the angle here, which is here, CAE. So these two angles should be equal. Do you get it?
Yeah, I see it.
Okay. So after you know these two angles are equal, you have an A. And second step, AC. They share the same line, which is share the line AC. Therefore, AC should be equal. Is that right?
Yes.
Okay, now you have S. Step 3 is the tricky part. How do we know DB is equal to EC? Because AB equal to AC. Therefore, 1/3 of AB equal to 1/3 of AC. We can just say, let's see, AB is X. And AC is equal to AB, which means AC is also X. And we know as ABD is 1/3 of AB, which means X over 3. And also here, AC and CE. So CE is also 1/3 of AC. Therefore, X divided by 3. Is X over 3 equal to X over 3?
Yeah.
Therefore, BD equal to EC.
Oh, okay.
So you have the second S. Therefore, you have SAS triangle. Do you see it?
Yeah.
Okay, nice. Do you want to keep going, or we just start for an hour? Or
How are you doing, Ilana? Is it a lot too much to take in?
No, I'm okay.
You're okay. So we have one more day tomorrow before Regents on Friday.
Yeah.
Yeah. So Michelle,
Sorry, I'm sorry.
that's all right. Jump in.
Middle of cooking and everything else. So,
I understand. Yeah.
this is for Edward too. So, in what you're doing with her, what do you feel she really doesn't know, should know? I mean, she should know everything, but what she doesn't know, what maybe she could focus more on?
she can focus on more about to prove the triangle are equal. So first, she have to memorize the 4 things. Like she cannot be messed with like AAS or SSA. That she have to memorize that the 4 things: SSS, AAS, SAS, and what's the third one? ASA. She have to memorize the 4 things. That's step 1. Step 2, she has to know how to use them to prove 2 triangles are equal. That's her weak part. So if she can deal with that, that's okay for her.
Okay, and do you think she picked up on it from the time you started till now? Or
Pardon?
do you think she's done better from the time you started with her till?
And yeah, she right now she can tell me why she think like it's like ASA, even though she is not like pretty right, but she already have the thinking. I can see like how she think, and we can find out why and where she made the mistake, and we can solve it. At first, she just like, okay, I don't really know how to prove it. Now
Yeah,
she can tell me like the side or the height or the line, and I can say, okay, it didn't tell you, so you cannot use it.
Yeah,
Even though it looked like it, but you cannot just say it's the same.
You said it very well, Ed. I think, Michelle, to answer your question, 1 or 2 problems ago, I mean, we had a similar triangle that you see on the screen, and Ilana jumped right to H and L as an answer. But with this problem, she knew H and L is not an answer because we don't know the height. So she's already problem solving her own, answers. So we're almost there, but are we quite there?
No, we're not quite there yet. And like I told her, she got to get there by tomorrow.
But definitely, she has some strengths. Let's play to the strengths. She definitely has some strengths. Some concepts are real solid and very very important. So she got those important things in place. So yeah.
All right, good. Yeah, and I like the switch of tables where you're not just going over the problem with her, you're actually asking her to solve it, to give you that stuff. So I don't have to keep hearing yes, 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 because she's a very shy person. So even that's an issue I have. Even in class, if she doesn't understand something, she won't say she doesn't understand. She'll yes you to that. So I like the fact that you kind of threw it at her. And forced her to give you an answer, whether it's right or wrong, but you forced her to give you that answer, and now we could really see what it is she needs help with. Thank you.
Right. No problem. I think, it's all about empowering them, right? We can give answers, but that's not going to help them at the end of the day.
Exactly.
At the end of the day, they had to come up with why, at one point she said, she had 15 as a correct answer, x equals 15, but her, her process was not quite correct. She had a right result, but not the process. So we had to go back and, explain to her why, x equals 15. You remember that, Elena? I mean, you just... You just...
Yeah.
But by the way, that's a good guess. That's a good guess. But just that the process was, it's not going to help you with any new problem. So, I think one thing though, Elena, what helps is, as you do some home, problems tonight or tomorrow, if you kind of run into the same roadblock again and again, you know what? I'm finding myself very difficult answering similar kind of problems. Then you could share with us. Then we'll see what is common factor in all of those, and kind of explain to you the concept. So we obviously thanks to you, Michelle, we have some more problems to work with.
Right.
But I think if Ilana can come back to us saying these kind of problems I always have difficulty with, so then we can kind of take care of those. But I think Ilana, I think your fundamentals are really good. You should really feel confident about that. I mean, is there some new? I mean, I learned myself too. I got a postgraduate degree, but still I learned myself something new too. So don't worry about it. And Ed is good in drawing you in and taking getting you to answer. So Ed, you're a good teacher.
Exactly. I couldn't help it with this. Trigonometry and geometry was like the devil to me. I didn't. And after I was done with the class or done with it for the semester, I never wanted to see it again.
Yeah, no, right.
And I got into college and got discrete mathematics. Well, I thought I would do trigonometry any day because discrete mathematics had me. Once I passed it, I was like, that's it. I never want to see this again.
Exactly. Yeah, I would run away from it, but. I mean, congrats, these kids, youngsters, Ed and Ilana, I mean, they're doing it much better job than we did. So
yes. Thank you so much.
Absolutely, thank you. And again, Ilana, just email me anything you run into again and again, then we'll take care of that. Okay. But you should feel confident. I think at the end of the day, you put in all the work, and that will come very handy on Friday. So you should feel confident.
So tomorrow again.
Yeah, Ed, are you available tomorrow at the same time?
I think so.
Okay, so we'll do it again tomorrow 1:30. I mean 4:30 for you.
4:30. Yep. Yes, thank you so much.
Bye, guys.
Bye.
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 By the way, Elana.
Yes.
Would you like the recording of this so you can go back and look at the problems?
Sure.
Okay, so give me an hour or so to finalize it, and I'll send it over to your mom's email.
Okay, thank you.
And you can send me more questions like we can go over.
Okay.
Because we almost finished your whole page, There's no more questions, so.
Or, when you go through problems, take a picture. Would that work, Ed? She could just take a picture with her phone and just, send it to us.
Yeah.
Yeah. All right, Elana, I don't want to keep you any longer. I hear, dishes clanking in the back, so it's probably dinner time for you. So have a good night, guys.
You too. Bye. Thank you.
Bye.
Bye-bye. Bye-bye. Good luck.